Hi students, this is Ms. Johnson with 6-3, Elimination using adding and subtracting. Our SWAT for today is we are going to solve equations using elimination. Alright, when do we use elimination? Well, we are going to use elimination instead of graphing when we have two variables, when it's not already in our y equals mx plus b form, because then it would be easy to graph, and when the coefficients, those numbers that are in front of the variables, when the coefficients are exactly the same or the exact opposite for one of the variables. And we are going to do some adding and we're going to do some subtracting. Well, how do you know when to add? Well, you are going to add when you have opposite coefficients, meaning one of them's a positive number and one of them is the exact opposite of that number. And when do you know to subtract? You are going to subtract when you have the exact same coefficients, the exact same number in front of the variables. This will make a little more sense when we do an example here. Alright, example 1. We are going to solve by adding elimination. And the two equations we have are 4x plus 6y equals 32 and 3x minus 6y equals 3. Now we could go ahead and turn these into y equals mx plus b form, graph them, and find where these two equations cross. But I'm going to show you how to do this algebraically today. And we know that we are going to use adding because when we take a look, our y variables, they have the same number in front, but they are opposites. One of them is a positive 6, one of them is a negative 6. So these are exact opposite coefficients. So we have 5 steps that we're going to go through and do today. Step number 1 is we are going to eliminate one variable. Well, we are going to eliminate the y's because they have the exact opposite coefficient. And so what we are going to do is, let me grab a pen here, is we are going to add these two equations together and we're going to do it going right up and down. So we're going to take 4x plus 3x to get 7x. A positive 6y minus 6y, these cancel out, therefore they are eliminated. Keep our equals, and 32 plus 3 is obviously 35. So now we have the equation 7x equals 35. Alright, step 2 is we are now going to solve for that remaining variable. So we are going to solve for x. We have 7x equals 35. So of course we need to divide both sides by 7, and when we do that we get x equals 5. Excellent, so we know what x equals, but we need to keep going. Step 3 is we're going to substitute x equals 5 back into any of the two equations that we started with. And I'm just going to choose the top equation. It doesn't matter, you could use the bottom one as well. So we've got 4x plus 6y equals 32, and we know x has to equal 5. So I'm going to substitute in, instead of 4 times x, we're going to do 4 times 5 plus 6y equals 32. Then as we keep going, as you could probably guess, we are now going to solve for the other variable. And as we do that, I have done some math already, that 4 times 5 is 20, and keeping the plus 6y equals 32. So now we need to solve for y. So of course we need to get rid of our positive 20, so the opposite is subtracting 20 from both sides. Okay, 20 minus 20 is now gone. We are left with 6y equals 12. And divide both sides by 6, divide by 6, and we are left with y equals 2. So our fifth and final step then is, now that we have figured out what our x and y are, is we are now going to write them as an ordered pair. As you recall, our x variable always goes first. X is 5, so I'm going to put 5 inside my parentheses, comma in between, and our y value is 2. What we have just figured out algebraically is if we were to graph these two equations, and let's say one of them goes like this and one of them goes like that, okay, what we have just found is we have just found the solution where these two graphs cross and it's at the point 5, 2. Now you don't have to graph it, you can just follow your 5-step process. Alright, so this was an adding example. Let's do one more that you are going to need to do a subtracting example. So we are going to solve these two equations by subtracting. We have the equations 2t plus 5r equals 6, and we have 2t plus 9r equals 22. Alright, we know that we are going to use subtraction for elimination here because as we take a look, our t's have the exact same coefficient. Both of them are a positive 2. So we are going to do some subtracting. And our 5 steps are exactly the same for adding and subtracting, except in our first step, when we're going to eliminate one variable, we are going to subtract. And when we subtract, I like to go through and put a subtraction line next to every single number on the bottom equation. So when we go ahead and subtract, again, up and down, 2t minus 2t, those are eliminated. Then we have 5r minus 9r, which gives us a negative 4r. And 6 minus 22 gives us a negative 16. We have eliminated one of the variables. Step 2 is to solve for our remaining variable. So if we've got negative 4r equals negative 16, we are going to divide by negative 4 on both sides, and so we get r equals 4. Step 3, now that we know what one of the variables is, we're going to substitute that back into any equation. And again, I'm just going to use the top equation. You can use the bottom one and it'll work out just exactly the same. So if r equals 4, we're going to go 2t plus 5 instead of times r, it's going to be 5 times 4, and it equals 6. Step 4, we are then going to solve for that other variable, so we are going to solve for t. Alright, so as we solve for the other variable, we now have 2t plus 20, after we substitute in, equals 6. So to solve for t, we need to subtract 20 from both sides. Let's see if I've got some more room. Alright, so 2t plus 20 minus 20, that is canceled out, equals negative 14. And divide both sides by 2, divide by 2, so t equals negative 7. Alright, and our fifth and final step is to write these as an ordered pair. Now we don't have x and y, but we always know that we need to put these in alphabetical order. So if we think Q, R, S, T, R comes first, so our R equaling 4 is going to be our first number, and T of negative 7 is going to be our second number. So again, if these two equations are graphed and they look like, I don't know, something like that. Oh, that's a really bad straight line. Pretend that that's a straight line. We know that the solution is right where they cross, right here, and according to our math, this is going to be at the point 4, negative 7. Alright, let's go ahead and get our summary going. Make sure that you probably have 1 or 2 questions. Make sure that you write that down. Thanks for tuning in. This has been 6-3, adding and subtracting using elimination.